Today I'm going to teach you how to use STK. STK, STK, K. Should be somewhere on your desktop, so if you just kind of look around in here, you'll probably find it. Okay, so STK 12, there we go. That's what I'm going to use. We'll let this thing load. And you may get a screen that says you need to save some files in your drive or whatever. Just go to a location in your main Google Drive. That should work. So we're going to click OK here, and then click through this. Multiple graphic card is fine. That might be different for yours. Okay, so now we're going to go to create a scenario. So we'll create a scenario. We can leave that as it is. There will be times where you're going to add some descriptions, etc. This one, again, it says my location that it's saving is in the C drive. You wouldn't be able to do that, so you probably had to identify a spot in your Google Drive. I want to change the start and stop time. So I'm going to actually click on here and change the stop time to select a date, and I want to select a date. For me, here's today's date. I'm going to select a date 1 week past this. That way the scenario will run long enough. Then you can click OK, and it will give you a default background like this, 3D graphics, 2D graphics, and it asks, do you want to select or insert an STK object? So right now, yes, we want to insert a satellite from the Orbit Wizard. So make sure that you click on satellite and then select Orbit Wizard, and then we click insert here. And just a few things that you should note here. There's some pretty neat things you can do. You can choose some different types of orbits: circular, critically inclined, geosynchronous, which is also geostationary, Molniya. Orbit Designer is a really neat one, because with Orbit Designer you can change these 6 Keplerian elements, and you can see how the ground trace is impacted with these things. So kind of we got a chance to play around with this one with the orbit mechanics.info thing the other day. So I'm just going to go to a critically inclined, and I want to hit apply on this, and when I do, I get a chance to see it sort of in the background here. I can't get rid of this other window, but I'm just going to choose that one for right now, and I'm going to hit OK. And then I'm going to close this window there. So now I have it critically inclined. It's a little hard to see it. So let's go to Window, and let's go to Tile vertically, and then I can see both these a little bit better. I can hit the scroll wheel to zoom in and out, and rotate this. You can see a little bit more about the satellite, and then I have the ground trace right here. So if we want to adjust the properties of this satellite, if I right click on this, and let me make sure that you right click on the word, there we go, satellite 1, I got to be on that thing, and click properties. Then I can go, and you can see the 6 Keplerian elements right here. Aren't they glorious? Yes, they are. I want the inclination for this to be 90 degrees. And if the word apply doesn't show up right here, you may need to click on this enlarge window here. So I'm just going to do that just so you can see. And I want to apply that. Let me shrink this down again. There we go. So if I do that, you can see now we have a 90-degree inclination. I'm going to do the 90-degree inclination. I like that one. I'm going to hit the X. So now I have a critically inclined 90-degree altitude, or 90-degree inclination here. And you'll notice that this is a type of orbit that you might, well, an example of one that I just showed in the previous model there. So what I want to do is I want to figure out on this how to determine the period of this. So I need to look at the ground trace that I got going on here, and I want to sort of play around with the ground trace. I want to show you how to do that and how to identify what is the orbital period based off the ground trace. So we first need to adjust the 2D graphics properties, and we're going to go into the details, and I want to change the latitude spacing to 10 degrees. I want to be able to see every 10 degrees. So then I hit apply, and you can see I see a lot bigger grid here. Love that grid. It's kind of my favorite grid. So the next thing is I need to see a few more ground traces. It's a little bit hard to see what's going on with this. So let's go up into the properties of the satellite. So I'm going to right click satellite. It would be the same thing if I right clicked it over here. And I'm going to go to properties of the satellite. So the satellite here, I have sort of my basic orbit. This is kind of what I played around with to adjust to 90 degree. I also have some 2D graphics that I can adjust, like the pass. So the pass is in 2D graphics window. That's going to adjust these items here. I want to show pass from first pass to the second pass. And so I need the lead type to be the current interval, which is from 1 to 2. And then I'm going to hit apply. And now you can see it showed a second pass in here. So it's showing from one particular orbit to the next orbit. And that's what I'm looking for. Now, if I leave it just from one pass to one pass and hit apply, it just shows one orbit. And so I can kind of see from here to here what that separation is. But I want to do 2. And then I'm going to hit play. And you're going to be able to see that as this satellite goes, and I'm going to speed up the simulation here, it goes down to here, and then it goes up to the next side. So it goes up to here. So you can see play and pause and reverse, okay? So in one orbit, the ground trace actually shifts to the left. So why does it shift to the left? Because the satellite, as it's orbiting Earth, and we can see as it orbits Earth here. Let me go in reverse here. I'm going to start this thing over. And pause. So if we go forward, as we orbit here, the Earth is spinning underneath it. Well, the Earth is spinning to the east, so the ground is actually shifting over here to the east. Well, we don't really want this map here to move, so instead of the ground shifting to the right, the orbit shifts to the left. So I need to find out, well, what is the distance between these ground traces, or ground trace I, if I make up a word. And so I'm going to scroll in to zoom in on this, and I'm going to look for a point of intersection on the grid line. So there is an intersection point roughly, and there's an intersection point roughly. Each line is 10 degrees, so I have 10, 20, 30, 40, 50, 60 degrees. I have 60 degrees from this ground trace to this ground trace. So from one complete orbit to the next orbit is 60 degrees. And I know that it is 4 minutes per degree. So if I do a little bit of math here and I go 60 times 4 minutes per degree, or I think your note said 3.99 minutes per degree, I get 240 minutes. 240 minutes is 4 hours. So right now I have created a 4-hour orbit. That's what this particular orbit is. And if I right click on my satellite and I go to properties and I adjust the semi-major axis, and I actually am going to make this thing 30,000 kilometers more. I'm going to make 15. You don't have to do this, but I'm going to adjust that and hit apply. Then you notice that, let me go back so you can see it, and watch this ground trace. The ground traces change. They actually get way further apart because I'm at a higher orbit. And when I get to a higher orbit, it takes a lot longer. So my ground trace is going to be significantly further apart. So that's about a point of intersection. 10, 20, 30, 40, 50, 60 degrees, 70, 80. So now I'm about 80 degrees instead of 60 per orbit. So that says it takes a lot longer to go around. So that's how you can measure how long the orbit is from one ground trace to the next one. I always like to find a spot where these ground trace lines intersect my latitude and longitude lines. It just makes it easier to track as you try to count these. So that's one way that you can count the number of degrees for an orbit. It's also the way that you can adjust your latitude lines. So I am going to actually right click this satellite, and I'm going to delete that satellite. And there's going to also be a situation where you may need to add a city. And so if I go into here and I click on insert and I click a new place, and then I can search by address and click insert, there might be a time when I want to add the city of Quito. So, and that would be Quito, Ecuador. So I'm going to leave you at that and let you go to the assignment.